So,
I think we should build them up for that.
She doesn't know it.
ready?
Yes.
So, yesterday we talked about what happens if a car hits another car and it bounces off.
Yeah.
We call that a bouncy collision. I want you to, if you didn't finish that data table or finish that chart yesterday, finish that first. You're going to do another chart. You can do it on the same board. Okay? Let's draw up the new one. This is called an explosion. Now, it's not a real explosion.
Alright, well then that's a misleading title.
I know. I'm going to draw
Real
it.
explosion?
I'm going to draw it. You guys draw along with me, and then we'll see what's up. You ready?
I'm tired. Is that stick it out? What is wrong with school?
Yeah, I don't like appreciate it.
No, because he's really trying to make it look less better.
And guess what time we did that?
Let me dream.
But we didn't get done until June.
Oh, are they connected?
I thought we were last day. That's my birthday.
Not exactly.
Yeah, so oh, we're trying this.
Yes, please.
Okay, I didn't need any like special peanut gallery. What? Bro, what?
All right. So, in this scenario here, it's like yesterday's, but instead of you pushing one and hitting the other, this one, you start with them, push together, and then let them go. Okay? You're going to start with them, push together, and then you're going to let them go. Okay? And what should obviously happen if you push these springs together and you let them go? What's going to happen? They should move apart from one another. Let's demonstrate that real fast.
Oh my gosh.
Want me to
What's
hold
the
the
difference between
camera?
this one and our other one?
I think we're good. I appreciate the offer.
All right.
Besides your title, Laura.
All right, so you watch it? So, this is the situation we have up front. Okay.
Yeah, you need a lifeguard.
So, what we're going to do is we're going to push them together like this, and then we're going to let them go. I will start first. Let's start with them at the same mass now. So, I'm going to push them together. I'm going to let them go. And what do you notice about how they move away from one another?
Same speed.
They do move away at the same speed. I think that's a really good observation.
But maybe we should put a weight on it.
Okay. So, oh gosh.
If there's a weight, the one that is heavier will go at a less speed, right?
So we're going to push them together and we're going to let them go. Okay. So if I were to add some mass to this one, okay, and now I push them and let them go, what do you think is going to happen now? How are the speeds going to differ from before?
Or one's gonna go faster.
Okay. What was that?
Everyone might be slow.
Have everyone slower. What did you say?
That's what I was saying. Well, I just said like the right one's gonna go faster.
So let's see if that's true. Is that what we saw?
Yeah.
Yeah, that actually looks really reasonable to me. Okay. So I'm going to push them together. I'm going to let them go. Is that cool?
Yeah,
Why is it that the more massive one goes slower?
because it resists the change in motion.
Yeah, that's right. So one of our conceptual frameworks for mass is that the mass is a measurement of an object's resistance to change in motion. More mass, more resistance. Therefore, less speed. And I think that's actually what we saw too. So I feel pretty good about that. I'm going to change this. Okay. So that's what you guys are going to do today. Okay? That's what you guys are going to do today. Let me give you a sense of what the graphs are going to look like and what your chart should look like. So you are going to We're gonna put the motion sensors on the edges again. You're gonna get a position time graph and a velocity time graph. Okay?
I didn't know it was that much. You did-
Now, one of the things that's challenging about this is that we're putting the sensors on the edges, which means that this car is moving toward the sensor. Okay? But the sensor thinks that anything moving toward it should be a negative velocity. So what ends up happening is it'll see this car at some distance away, and then it'll start moving toward the sensor. So that's for this blue car. And then the velocity is 0, and then you let it go, and it drops to some new velocity. Okay? The red one is going to be something similar, but you said it's going to be moving faster. So
Oh, making my neck itchy. We didn't sprint it just now.
So it has a little bit of a steeper slope because it's going to be moving faster. And that will manifest on this graph as being a larger negative velocity. Now, here's the actual problem with this. The actual problem is signs matter.
Wait, which one's the new one?
Okay? Signs matter. So what direction is this guy moving?
Which one's the red one? The one underneath it?
Yeah, the reds are underneath.
Okay, and then the red represents the weight?
The red is the one without the weight. Okay?
It's colorblind, people say.
I know. I know.
is? A little.
It's because he's not wearing his glasses.
I'm not like my glasses.
I'm colorblind with certain colors, but when it's far away like this, I also have like this thing where I can't really see that good.
That's fine. You're good, man.
So that makes it worse. So my glasses help me see far away, because I don't know which person.
Listen. Don't miss this part because you're going to need this moment. You're going to have to reflect on this moment. Because each car is moving toward a sensor, their velocity is going to register negative on the graph. But what direction is the blue one moving? It's moving left. So what is true about its velocity?
Negative?
It is negative because it's moving left. And what about the right one here? So when you go to draw the chart, okay? When you go to draw the chart,
The same chart as yesterday?
yes,
Okay. Sounds like a plan to me.
me too.
Well, you can hear.
I said fast person.
Okay. Do you want me? I want to. You're a good fisher.
All right. So you're going to push them together. You're going to let them go. You're going to measure the velocities.
Do we need another one of those charts?
The velocities you're looking for are here. Is that enough to get started?
We need, so we need two charts? Right.